Good morning, students. Next class, logical micro operations. So the major logic micro operations are AND, OR, exclusive or not. These are the major logic micro operations. That is AND, OR, exclusive or not. Okay. The logical micro operations specify the binary operation for strings of the bits that is the register. These operations consider each bit as a register separate the variables. For example, the exclusive or the operation content of register R1 and R2 symbolized the P colon R1 to R2 and exclusive or of R2. And we can implement the specify of the logical operations can be executed on the individual bits of the particular register is provided to the operations, and the major logic operations are AND or exclusive or not, and we have to assign that different type of operations and the special symbols will be adapted for the micro operation, that is OR and exclusive or not, that is the complements and of the symbols and symbol or symbols and A and D and different of symbols we can use in logical micro operations. See, for example, P plus Q, that is R1 is to R2 plus R, that is R2 plus R3 will be transferred to the R1, and R5 and R6 is transferred to the R4. And between the plus between P and Q is an OR operation between the two binary variables of the control functions. The plus will between the R2 and R3 specify the add micro operation. Then the OR micro operations is designated by the symbol OR symbol between the registers of different registers, that is R5 and R6. And the hardware implementation of the logical micro operation requires the logical gates instead of each bit or pair of the bits the registers to perform the required logical function. In that hardware implementation, we have to implement the logical function. Although there are the 16 logical micro operations to perform, there are computers with only 4, that is AND, OR, exclusive or complement. This is AND, OR, exclusive or and complement. Okay, and see here this figure shows the one stage of circuit that generate the 4 basic logical micro operations. It consists of 4 gates and multiplexer. This is the 4 gates and one multiplexer we can use. Each of these 4 logical operations is generated through the gate that perform the required of the particular operations. Okay, and there are to perform the gates applied to the data inputs and the multiplexer, the gates and direct operation will occur. The diagram shows one typical stage with the subscript for the logical circuit, that is the one of the circuit, and here the perform the operators in the n times, and I equal 0, 1, 2 and n minus 1. The selection variables are applied to all the registers. The function table is here assigned. S1 is 0, 0, the equal to A and B, the operation AND, and 0, 1 you perform the OR operation, and 1, 0 it performed to the exclusive OR, and 1, 1 it performed to the complement operations. Okay, it is one of the, it is called as one stage of logic circuit. Here we can use the different of gates and using the multiplexer and using the S1 as 0, then selection of S1 as 0, and we have to perform the different type of operations, that is 0, 0 we can AND operation, 0, 1 we can use OR operation, 1, 0 we can use exclusive OR operation, 1, 1 we can use complement. And list of micro operations. Here with the help of 2 binary variables the following micro operations are performed. See, x y 0, 0, that is the 1, 1, 1, 1, and 0, 1 is the operation, and 1, 1 and 1, 1. Okay, the 16 Boolean functions are variable x and y is implemented. See, f0 equal to 0, then is the clear, f1 x comma y, that is the AND operation, x y dash, that is the complement A and B complement, f3 equal to x, that is the transfer of A, f4 x dash y, that is A complement and B, f5 equal to y, that is transfer B, and f6 exclusive OR of y, that is we can perform the exclusive OR operation. X plus 5 we perform OR operation, and x plus 5 whole dash, that is NOR NOR operation, and x exclusive OR of 5 whole, that is exclusive NOR operation, and F10 there is a complement B, and F11 we can operations X, F12, F13, F14, F15, that is we have to perform the 16 logical micro operation derived from these functions by replacing variables x by the binary content of register A and B variable and the binary register B. It is important to realize the Boolean variables, how it will perform the different of operations and two binary variables of x and y. The logical micro operations listed in the second column represent the relationship between the operations and content of A and B, and each of bit register treated as the 4 binary variables, and the micro operations is performed the string of bit stored in the different type of registers. And in the some of the applications of logical micro operations for manipulating the individual bits or a portion of a word stored in a register, they can be used to change the bit value of delete a group of bits and bit value into the register. The following example shows the one of the register designated by A are manipulated to the by the logic micro operation as a function of the bits and the register manipulated B. In typical application, we can select the one of the operation is selection set operation. It is set to 1 the bit in register A where the corresponding ones in register B. It does not affect the bit position that have B. The following example is C 1010 and A and B 110, that is 0 1 1 1. After A 1110, the two leftmost bits of B are 1, so the corresponding bits of A are set to one of these two bits as already set, the other has changed the one of the other bit. Okay, and go for the selective complement operation. The bits in A where then the corresponding ones in B, it does not affect to the bit position that have zeros in B. Example, that is 1010 A and 1100, that is after 0110. See, again the two left nodes of B are ones, the corresponding bit to A are complemented. Okay, left verbs are 2 are complement, it will be A is complement, that is 0. So this example again can serve truth table from the which one of the deduce that the selective E complement operation, that is the exclusive or micro operation, can be implemented into the selective complement operation. See, in select set operation 1010A and 110, it will not affected, and 1110. In selective complement and leftmost bits are true or equal, then it will be complement 0, it will produce to the 0. And selective clear. See, the selective clear operation, it clears to 0 the bits at the bits A only where then the corresponding ones in B. Okay, see here only once in B it will clear to 0. See here 00 as 00 101, but here B here the 11 it will be asked to the 0. So that is called as a selective clear, that is the clear to 0 the bits A only when the corresponding ones in 0, that is 1 since B is the 0. And what is the mask operation? The mask operation is similar to the selective clear operation, except that the bits of A are other than 0 A or other than cleared only where there are corresponding zeros in B. The mask operation is AND micro operation from the following operation. There is the AND operation you have to perform the 00 101 010 1. So AND operation means both are 1 it 1, otherwise it will be 0. In mask operation we perform the AND operations. Okay, and go for the clear operation. See, both are 0. 1 1 0 0 0 or 0. That is, the two rightmost of bits are cleared because the corresponding to the ones. The insert operations, okay, the two leftmost are left unchanged because the corresponding bits are B, and once the mask operation is more than to the one of the application built operation. So it is a clear 1 0 1 0 0 0 1 1 0 0 0 0, that is A plus B. And also we can perform the insert operations. Also the insert operation is a new value into a group of bits. This is done by the first masking the basis and then ORing with the required the value of the example. Suppose that the value of the example of the value of the particular register contains 8 bits 0 1 1 0 and 0. The replace the 4 almost with the value of 1 0 0 1. We first mask the 4 wanted bits. Then the mask operation is an AND operation, and the micro operation, that insert operation, is an OR micro operation. So the clear operation compare the words A and B and produce all zeros, result that two numbers are equal. If in the clear you can say that in the clear both are equal, it produces 0. Okay, when A and B are equal, the two corresponding bits either both 0 or both 1. In either case, exclusive operation produce 0. The all zeros are resulted. Then check the determine if the two numbers are equal. So here you can use the different type of operation, that is a selective set operation, then selective complement operation, then selective clear operation, and mask operation and clear operation. Then go for the shift micro operations. In shift micro operations, we are used to transfer the serial data. That is, transfer to the serial transfer of data. Then they are using the conjunction of with arithmetic, logic, and other data processing operations. The current of register can be shifted to the left to right or left to right, and it will form to the different type of bits will be, and it to the first flip-flop receive the data from one to the another. Okay, and we can assign to the different type of operations, that is the logical shift, circuit shift, arithmetic shift. We can implement the different type of operations. In the logical shift, one that the transfer 0 to the serial input, we will use the symbol SHL, that is a logical shift right and logical shift left. Okay, and CAL is circular shift left and circular shift right, and ASHL is arithmetic shift left and arithmetic shift right. So different type of shift micro operation we have to perform, that is SHLR, that is shift left register R, SHR or shift right register R, CAL circular shift left register R, then circular shift right register R, and arithmetic shift left R and arithmetic shift right R. Okay. And here this is a shift left operation and shift right operations, and the bit positions is shift position, that it will be changed to the shift result 1 and shift result 2, shift left and shift right, and count 1 count 2 to the perform to the different type of shift left registers. And circular lift, the bit position, and arithmetic shift left and arithmetic right, and the hardware implementation. See, in the hardware implementation, a possible choice for all the shift unit would be bidirectional and shift register with the parallel load. Okay, and information can be transferred to the register in parallelly, and it will perform to the operation to the register of the type of the configurations. And in this type of configuration, a clock pulse used to needed for loading the data into the register, and another pulse is needed for loading the processor within the many registers. It moves to the efficient of the particular instructions that will be implemented to the shift operation in the combination circuit. In this way, the content of the register that has been shifted in the first place onto common bus whose output is connected to the combination shifter. See here, we can apply to the different type of multiplexers 1, 2, 3, 4. Then we perform the different of serial input IR, and 0 is the shift right and 1 from the shift left, and the serial is the IL, and A0, A1, A2, A3 we can implement to the particular operation. In the combination circuit, shifter can be considered the multiplexer. Here the 4-bit loader, 4-bit data inputs A through A32, and the 4 data outputs, that is H0, H1, H2 and H3. There are 2 serial inputs, one for the shift left and another for the shift right. That is the 0 for the shift right and down, and 1 for the shift left up. Okay. And other shift right IR, when the selection of inputs is equal to 0, then H1 equal to IR and A0, A1, A2, and S equal to 1, the A shift with the data processing, it will be transferred to the A1, A2, A3 and IL. Next, arithmetic logic shift. Instead of having an individual register performing the micro operations, the computer system employed a number of storage devices. The register connected to the common operation. It is called as arithmetic logic shift unit. And abbreviation to perform the micro operation, the contents of specified registers are placed into the inputs of the common ALU, that is arithmetic logic unit. We can perform all the, so ALU, the one stage of arithmetic logic and one stage of the logical circuit, everything will be one stage. It will be perform the particular shift operations, and the result of combination circuit, that the entire register transfer operation from the places during the clock pulses period. The shift micro operations are often to implement to the during of the clock pulse period. The shift micro operations are often performed in a separate unit, but some of the operation will be performed. The shift micro operation logic and shift circuits introduce the previous sections, but it will be combined all the things in one multiplexer. It will be performed the one ALU operations in the subset of the design to the typical stage inputs and A1 and B1, that is AI and BI. Okay, and shift left, shift right, can AI minus 1 and A plus 1 is a shift right and shift left, and then the serial inputs S0, S1, S2 and S3. See here the function of the table of the logical unit. See here S0, S1, S2, S3, Cn equal to 0. The operation F is equal to A, that is transfer A, then Cn equal to 1, then F equal to A plus 1 increment A, then if S1 is S0 equal to 1, that equal to addition operation, C1, Cn1 and S01, that is add with carry operation, and 001, that is the subtract with borrow operation, and 101, that is subtraction, and 011, that is decrement A, that is all the ones, that is transfer of A, and 001, that is end operation, and 101, that is OR operation, and 11, that is exclusive OR, and complement A, shift right A and shift left A. So we have to perform that different type of operation and different type of functions, that is transfer A, increment increment A, addition, add with add with carry, subtract with borrow, subtraction, decrement A, transfer A, end operation, OR operation, exclusive OR, complement A, shift right A to F, that is shift right A to F, and shift left A into F. So different type of see here the first 8 operations as performed to the logical arithmetic operations, that is S1 is S2, S1 is like 0 0, like S3, S2, that is See 0 0 0 0. These 8 operations are performed. Arithmetic logical operations and are selected to the S3 and S2 are equal to 0. And the next 4 logical operations that are selected S3 S2 equal to 0 1. See here S3 0 S2 1 S3 0 1 0 1 0 1. These 4 are performed to the logical operations, and the next other operations are incremented to the last 2 operations are shift operation and are selected to the 1 1. The last operations is selected 1 1. It will perform the shift operations. Okay, so likewise we have to perform the different type of shift logical operations. Okay, see the first 8 S3 S2, these 8 are the arithmetic, these 4 are logical, these are the shift operations. Okay, so likewise we have to perform all the operations in the one circuit. This is the arithmetic logic, is one stage of arithmetic logic shift unit. Okay, thank you.